All right, hello and welcome back, ALEKS students. So this is an ALEKS topic that's called Ranking the Screening Efficacy of Atomic Orbitals. This was, again, a requested video, so thank you very much for the request. I will be, answering these as quickly as I can as you comment below. So please do feel free to keep commenting. Let me know what else you'd like to see. So this video, I'm going to do two different instances of this topic just to give us a little bit more practice. You can see I've already made some notes here on what we're looking for, essentially. And so the idea of screening is basically it's a measure, or it's an estimate of how likely is an electron in these orbitals to be in between the electron in question. So in this one, it's an electron in the 6f orbital. How likely is the electrons in these orbitals to be in between the nucleus and this electron? That's essentially what screening is. It's shielding this electron in the 6f orbital from feeling the effects of the nucleus. And so the closer in to the nucleus, the more effective these electrons are going to be at screening or shielding this electron in the 6f orbital. So essentially what we're looking for is which electrons are closest to the nucleus and which electrons are closest to the electron. And in this case, when I say electron, the electron in the 6f orbital, 6f orbital electron, right? That's really what we're talking about for this topic. So let's go ahead and work through this. Now, the least effective is actually going to be pretty easy because it's an electron in the same 6f orbital. So if we're looking at electron in the 6f orbital and there's another electron in the 6f orbital, it's not going to be effective at screening at all, maybe just a tiny bit, but it's definitely going to be the least effective. So we can, if we see that, you can always start by saying, well, that's definitely going to be number 4. And then essentially what we're looking for, and usually what I like to do is figure out what's number 4 and what's number 1, and then sort of fill in from there. So it's going to come down to 4s or 4d. Now, the s orbitals, there's only going to be that one s orbital, right, in whatever energy level you're talking about. And there's going to be 5 d orbitals, 3 p orbitals. But in terms of which one of these is going to be more effective, the s orbitals are always going to be more effective in the same energy level. So it would go spd, where the s orbital is going to be the most effective. So this would be number 1. Then this would be number 2, and then obviously then this one has to be number 3 because it's a 6s orbital. It's going to do a slightly better job than 6f because the s is going to be, like I said, in a given energy level, it's going to go spdf. So 6s is going to be better than 6f, obviously, and then s is going to be better than d for that level 4. So let's do another one and just do a little bit more practice. So in this one, we've got a 4d electron, so an electron in the 4d orbital. So then we've got 2p, 2s, 4s, and 4d. So again, just like last time, if it's in the same orbital, if the electrons are in the same orbital, they're going to do the worst job of screening or shielding. So that's going to be number 4. And then we've got, pretty similar to last time, 2p, 2s. So same energy level, the s orbital is always going to do a better job. You can think of it sort of, it's lower in energy. It's closer to the nucleus. So this is going to be 1. This is going to be 2, and then obviously then that would have to be 3. Where our 4s is going to be, got confused there for a second. The 4s is going to be better at shielding, so it's got a lower number than the 4d, right? The 4d is going to be the worst, and the 4s is going to be slightly better, but not as good as these lower energy, right? Lower energy is always going to be better. So 1, 2, 3, 4, like that. So hopefully that makes sense. If I confuse you there at the end, maybe start the video over and don't get confused there. But leave a comment below if there is something else I want to you would like me to touch up on here. But basically, take home message: most effective is going to be closest to nucleus, and so then that's going to be S, and then P, and then D, and then obviously F. And then obviously the lower the energy, the lower the principal quantum number, the lower the energy level, the more effective it's going to be. And then the least effective is going to be the closest to the electron in question. So, higher numbers, or, f orbitals versus d orbitals, so on and so forth. All right, hopefully that's helpful. And thank you again for the request.